Today's notes cover the Pythagorean theorem. When two of three sides of a right triangle are known, and we're talking about right triangles, the third side can be found using a Pythagorean theorem. So here are the parts of the triangle. You have two legs and a hypotenuse. The hypotenuse is always across the box. So the box is, of course, your 90-degree angle. Usually the legs are indicated with an A and a B value, and the hypotenuse is C. But sometimes it's X, Y, and Z. So here's your Pythagorean theorem. A squared plus B squared is equal to C squared. If you're solving for C, well then C squared is A squared plus B squared. If you're solving for A or B, well, A squared would be C squared minus B squared, and then, well, you would square root, and that's how you would get A by itself. I guess we should probably go ahead and, if we're solving for C, then you would square root it, and it would just be the square root of A squared plus B squared. All right, so those are all the different varieties of the Pythagorean theorem. So a common error is not locating the hypotenuse correctly. The hypotenuse, again, it's always across the box. It is the longest side on your right triangle. It doesn't really matter which leg you identify as the A and the B. These are the legs that meet at a right triangle, or at the right angle. So in this first example, we're trying to find a leg. I know it's a leg because across the box is the hypotenuse. And so I'm just going to call this guy like A and this guy B, and well, I'll call this guy C. All right, so A squared plus B squared is equal to C squared. And I'm squaring the square root. All right, so let's see. I want to go ahead and clean this up a little bit. And when you're squaring a square root, you're squaring both of those factors. And so this equals 36 times, because 6 squared, and then the square root of 2 squared is just 2. So that's what it would look like. Okay, so x squared is equal to 72 if I multiplied it. Now subtract 36 on both sides. And then if I take the square root, x is equal to 6. In this case, normally when you take a square root of something, you would have a positive and a negative value. But because it's the length of a side of a triangle, it's only going to be the positive. All right, let's try example 2. Find the value of x. Again, let's see, across the box, this is our hypotenuse. A and B really don't matter. I can call this one A, this one B. The hypotenuse is always going to be your C. All right, so 3 squared plus 7 squared is equal to C squared, and 9 plus 49 is equal to C squared. If I add these together, that's 58. And take the square root, so C is equal to the square root of 58. All right, so that's what it would be as an exact number. Let's look at Desmos and see what the decimal approximate would be. So I'm looking for the square root of 58. I'm going to pull up my Desmos app, and this is a free app. You can also go on online and do that. So I do square root of 58, and that gives me about 7.62 if I round to 2 decimal places. So C is approximately 7.62. Okay, example 2, find the value of x. All right, so this is not a right triangle, but if I drew a perpendicular straight down, there's my right angle. Let's see, across this way would be 5, so that means this would be 6 because the sum of 5 and 6 is 11. All right, and then this guy would be 8. So really I'm looking at, I've got an 8, I've got a 6, and I've got an x. Across the box is the x. This is your hypotenuse. I'm going to go ahead and call this guy A and this guy B. So A squared plus B squared is equal to C squared. Of course, your hypotenuse is C. So 64 plus 36 is equal to C squared. If I add those together, I get 100. And I take the square root, so C is equal to 10. And that's the value of x. Last example, find the value of x. Okay, so I can see that this is a square because I have the 4 congruency marks. And squares have sides that are congruent. And so I'm going to go ahead and just label this guy an x because he's the same value or the same length as this guy. So it's going to be x squared plus x squared, and the diagonal across the box, my hypotenuse, is equal to 5 roots 2. All right, so let's see. X squared plus x squared give me 2x squared. And, I need to square this side. It's a squared plus b squared equals c squared. Just like before, we'll distribute the square. And so that's going to give me, well, 25 times 2. 5 squared is 25. Square root of 2 squared is 2. 2x squared is equal to 50. Divide both sides by 2, and x is equal to 25. And we take the square root, so x is equal to 5. One of these sides of our square is 5 units long. And that's the Pythagorean Theorem notes. Please ask questions if you have any.